In Chapter 9, we are going to talk about trigonometric identities and equations. So we have four main sections we're going to work on, 9.1, 2, 3, and 5. Let's get started with 9.1. So in 9.1, we're going to start focusing on identities. There are some facts that you have to know by heart. And the first one is going to be a direct result of the way that our unit circle works. The x squared plus the y squared equals 1. If we draw a triangle, it's always going to build that same relationship. So sine squared plus cosine squared is equal to 1. Now, if we divide everything through by sine squared, we get the next one that we see right here. 1 plus cotangent squared is equal to cosecant squared. If we divide everything through by cosine squared, we get the one that we see here. So they all directly come from the fact that sine squared plus cosine squared is equal to 1. Let's talk about the even and odd identities. As we were graphing these, I was showing you what happens. These ones here are even. They actually have y-axis symmetry. These ones here are odd with origin symmetry. And these ones here are even with y-axis symmetry. If I could write the word symmetry. The only ones you have to have memorized are these top three. If you know that the negative on your inside of your sine will come out in front, the negative on the inside of a tangent will come out in front, then the reciprocals just happen. And then cosine, if you put a negative, because it is the only one with even y-axis symmetry, the negative goes away. So you are going to have memorized the 6 that we see right there with the stars on them. And we will have a memory quiz over those particular things. The next facts that you will have memorized are the 3 that you see here. Sine is 1 over the cosecant. Cosine is 1 over the secant. Tangent is 1 over the cotangent. Now, why do you not have to memorize these? Well, they're just the flip-flop of the ones you see there. And then our quotient identities are what is the fraction that makes the tangent or the cotangent. So those are the quotient identities. So tangent, remember, is sine over cosine. Cotangent is cosine over sine. Now, all of these are identities. They are facts that are true for all of our trig functions and all thetas that are in the domain for those trig functions. So that's why we call them identities, and they are going to be used for us to find equivalent statements, solve equations, do lots of things too. So you have to have those items memorized. So this is all of them summarized The ones you have to have memorized are the first three on the Pythagorean identities, the first three even and odd identities, the first three reciprocal identities, and then these last two about the tangent, cotangent, secant, and cosecant. So at this time, please take a screenshot of this. So you have all of them on one page, so you can use them to study for the memory quiz, and so that you have them for easy reference. So take a screenshot of that page, make sure you have that for your use as you go through this process. But again, eventually you're going to have those memorized. Now, I'm going to show you ways to do these problems without having to build a triangle. Now, because of the fact that we know some other things about our trig functions, so there are more than one ways to do these problems, okay? Now I'm going to show you the quickest way, okay? So the first one says the cosine is 3/4, okay? The long way would be to build a triangle with a 3 adjacent, a 4 opposite where it's positive, and then find the secant. So that's one way to do hypotenuse over adjacent. So we can do what we've always done, okay? But another way is that we know the secant is 1 over the cosine, or the reciprocal identity, so that's 1 over 3/4, which is the same as 4/3. So just by using the fact that they are reciprocals, since 1 is 3/4, 1 over 3/4 is the same as 4/3. Okay. Now, B is a little different. So let's look at what we know. If the secant is 5/4, we know the cosine. If the tangent is 3/4, we know the cotangent. Those don't help us too much. We have an identity. So instead of building a triangle with, like an opposite as 3 and a hypotenuse of 5 and an adjacent of 4, you could do that. You could do that. It's perfectly legit. But what we can do is we know that tangent is sine over cosine. Now remember, the cosine and the secant are reciprocals. So we get for free that the cosine is 4/5. Okay. Now let's fill in what we know. The tangent is 3/4. I'm looking for the sine. The cosine is 4/5. So rules of proportions, rules of equations. If I'm dividing on one side, I can multiply on the other. So this is just 3/4 times 4/5 would be our sine. So our sine value is, if you cross out the 4's, you get 3/5. Now, could you have built a triangle? Sure. What we're trying to do is come up with the algebra that goes with these, so we don't always have to draw the triangle. Now, again, we could find where the cotangent is positive, but the cosine is negative. That would be down in our fourth quadrant. We could make that 2 over 1. We could build a triangle where our adjacent is 2 and our opposite is 1. They would both be negative. We could do that whole thing, okay? But we also have some facts. Here's the first fact I know. Cotangent is the flip of the tangent. They didn't ask for tangent, so it's not helpful. But I know that there is a Pythagorean identity that says that the cotangent of theta squared plus 1 is the cosecant squared of theta. Okay? Now, how is that going to help us? Well, I know the cotangent squared plus 1 has to equal the cosecant squared. 4 plus 1 is 5. So I know that the cosecant has to be plus or minus the square root of 5. So I know that the cosecant and the sine are reciprocals of one another. So I know my sine is 1 over square root of 5. Now, which is it? Is it positive or negative? Well, because the cosine is negative and the cotangent and cosine can make a cotan be positive, then we know that this has to be a negative. So our sine is negative square root of 5 over 5. Okay. Now, we still have to find the cosine. There's so many ways to do these problems. If we built the triangle, we could do that. This is radical 5. So the cosine is negative 2 radical 5 over 5. So that's one way to do it. And I'm still okay with you doing it. But let's look at something we know. If the cotangent is 2, the tangent is 1/2. But remember, tangent is sine over cosine. So if we get sine over cosine, well, let's put the actual cosine there. If we cross multiply, we get the cosine over 2 is negative radical 5 over 5. And all we have to do to get rid of that 2 is multiply both sides by 2. And we get that the cosine is negative 2 radical 5 over 5. Did I have to build a triangle? No, I did not. So the beauty of these identities is by combining some of those facts, we can actually find some of our different trig functions by using some logic in the facts that we have without building a triangle. If you want to build that triangle, you go for it. But as you can see mathematically, I didn't have to. The last set of example I want to go over for 1B are the simplifications that we see here. Now, what we want to do in these simplifications, now these are actually, it's kind of strange, these actually become a little bit harder than the examples we're going to have later on. But what we're trying to show here is we can use algebra to simplify these things. Okay. So how could I use algebra to simplify these things? Now, I'm going to write some of the facts along the top of our page. So sine is 1 over the cosecant. Cosine is 1 over the secant. Tangent is 1 over the cotangent. Sine squared plus cosine squared is equal to 1. 1 plus the tangent squared, I should probably put a theta there, is equal to the secant squared. The cotangent squared plus 1 is the cosecant squared. Last two we have to have memorized. Tangent is sine over cosine, and cotangent is cosine over sine. Now, I didn't include the even and odd ones. Those are my least useful for all of these purposes. So I'm not worried about those ones right now. You just need to focus on, for this first set of problems, for the 8 that you see up there. Okay, so you need to focus on the reciprocal, the Pythagorean, and the quotient. Okay. So we have all these facts that we can use to help us. Now, I don't mind that we have a 1 over the cosine there. What I see is I see ones and sines, and I see things right here that are ones and sines. So sine squared plus cosine squared is equal to 1 is an equation. It can be rearranged. So if I subtract a sine squared from both sides, I get that cosine squared is 1 minus sine squared. Now that's a trick we're going to see very often, so make sure you get used to using that little trick. And so this is equivalent to a cosine squared. So by our rules of substitution, we can substitute in cosine squared wherever we see 1 minus sine squared. They're equivalent. So we really get here cosine squared divided by a cosine, and so our final answer is a cosine. So the job that you have with these problems is to take something that has maybe lots of trig functions in it and reduce it down as far as you possibly can using the rules, the 8 rules that you see up there. Okay? So the final answer for that is cosine. Now let's try a few more. So when you see lots and lots of trig functions kind of messed up, my idea, that what I always do is I change them to be sines and cosines. So I'm going to make this be 1 over sine because it's a reciprocal. That's already a cosine. I'm going to leave it alone. But cotangent is the same as cosine over sine. Okay, so you'll notice the only thing I have in my problems are sines and cosines, and that's a trick that you want to use very often. Okay, so I'm going to combine these cosines together, just in that notation, so they look a little nicer. And then what I notice is I have common denominators. Common denominators mean that I can add or subtract the tops and write them over one denominator. Now earlier I told you that sine squared plus cosine squared could be rearranged, and it can. And one of the ways to do that is to move the cosine over, and we get that sine squared is 1 minus cosine squared. So anytime you ever see ones and squares, think, what can I do to a Pythagorean to make that match? Well, 1 minus cosine squared, that is the same as a sine squared. So let's replace it. So we get sine squared divided by sine is the same as a sine. Let's do one more. So I have lots of trig functions. I don't want to have lots of trig functions. So I'm going to replace anything that I do not see a sine or a cosine. The only one that's messed up is this one, but tangent is sine over cosine. So take out anything that isn't a sine or a cosine and replace it. Now what happens? Well, this and this can cancel out. Now there's a few different things you can do here. You can use the same replacement we did up here, that sine squared can be replaced with a 1 minus cosine squared. That's one tactic. You can factor out a sine. So that's what I'm going to do. They both have a sine. Let's take out a sine. Now let's think, if I divide by sine and take it out, I have to leave a 1. When I divide by sine and take it out, I have left over a cosine squared. Now what is 1 minus cosine squared? 1 minus cosine squared is sine squared. So this is a perfect replacement with a sine squared. And then we have 3 sines multiplied together. Our final answer is sine cubed. So now you're ready to do these. And in this 9-1A homework, expect it to take some time. So there is 9-1A. It will get easier as you go through things. And we will probably do some of these problems together. There you go.